All right, let's get started. Why don't we start with Anant today and go down?
Yeah, I'll short. I As I was reading through, it reminded me so much more of like the modern sort of cloud infrastructure, like architectural plans that you often see with modern applications. It's kind of seems like a different not marketing term, seems like a different way to define the same idea at some level. And this felt more um idealistic in some sense in terms of how they had certain values on managing these resources. I also found it interesting that uh, the uh, the sort of the consortium of people or universities that were participating in this is not the typical consortium of universities or East Coast or West Coast universities that was part of like other types of uh, I guess internet connectivity testing and distributed systems test projects or pilot projects. I thought that was interesting, and but many of the things seem to resonate with what's happening today. Like one example again that stood out to me was the initial agent worker and like agent matchmaking and resources and matchmaking resources and planning and scheduling for it. It reminded me much of like what. Oh yeah, the user problem solver agent matchmaker resources. The architecture reminded me of like how uh, sort of AI copilot or LLM copilot applications is kind of thought of in terms of having an, and the idea of problem solver ahead of an agent here, it seems like a good way to think about that because that those things typically start at agent level and the tools and the resources that you can provide for the agent. But this seems there was one level higher up to that, which is sort of like a the name was interesting, the DAG man, directed acyclic graph man. That was interesting in terms of a declarative intention of what it is, what a particular execution is looking for. I thought that was interesting. I also found this the particle physics grid. I guess that was the like one of the particle physics data grid. That was one of the participating groups, research groups that was experimenting with this. That was a very interesting uh, slideshow that I found. I will just share it in the comments. But uh, yeah, so I'll stop there. Those are some interesting things or things that I thought was useful for me. I'll pass it on to Ben.
Yeah, so I also have never heard of Condor, but in the beginning I saw it mentioned load leveler, and I'm not sure I used load leveler directly or something that's very similar to it in my PhD work. I did some supercomputing simulations, and they have a like a load leveler or some other load controller that you end up trying to send your jobs to, and then have them execute. Um, and and this is more like sort of applying that model across a distributed system where you still have some sort of like, not only do you have hierarchy, but you have static hierarchy, um, where you have like this was this M node or stuff like that, where basically, yeah, I mean, basically each node is in control of its own resources in the sense that it can always turn off. That's why they were talking about in the beginning about leave the owner in control. But there's still like from what I can tell, and maybe I'm not understanding Condor perfectly, but it seems like it's the case where like there's some node in the center, the matchmaker, um, to that introduces and is the coordinator for the system. And of course, there's the idea of nodes can leave at any time and so on. But at the end of the result, you still have this sort of hierarchical coordinator. And I feel like and with to talk about the things that I work on with blockchains and so on, it's trying to think of not only how can we economically incentivize stuff so it's not 100% altruistic like these sort of systems appear to be, like they mentioned that in the beginning, but also how do we have a system where we don't have like a priori matchmaker or leader or coordinator, and try to build the system out of the parts, maintaining the idea that anyone can leave at any time, and while also not having, a single sort of coordinator either. But this is perfectly acceptable for what it's trying to do. I'm not sure I have any other thoughts on that. It's just, interesting to see how they, put this. It's quite an old paper, but there's distributed computing for a long time. Anyway, I think I'll pass it down to Sachin.
Uh, yeah, really interesting to read, and yeah, I mean, almost like too neat to believe. I don't know why. That's sort of my first intuition I had was that it feels just extremely um, idealistic, but yet working. But yeah, and I guess maybe part of the reason is that it seems like it's mostly used in like academia and college institutions and stuff, and maybe there's less risk of malicious actors or like unpredictable activity. So this sort of thing works because it's kind of like the workload and the type of people who use it is pretty predictable. Perhaps like everybody is more like it's like a highly aligned corporation, even if they are all in different institutions or whatever. Uh, so so that may be why uh, it seems to work and has existed for so long. And yeah, the first part of the paper really stood out, like the principles, and I felt yeah, it could sort of overlap with a lot of like things we have read in online governance studies. Uh, yeah, leave the owners in control, whatever the cost. I think this is. I was thinking about, like evolution of things like podcaster, Mastodon, and everything, and it seems like a big, maybe perhaps a big reason for uh, more adoption of like podcaster is that it sort of like it sort of gives you the agency or uh, yeah, it makes you believe that you are in control, and I think that's part of the reason why people, even if you don't use those controls that often, like I only use like the single podcast or client, and I don't do anything else that I don't do on Twitter, but there is this possibility of agency that is appealing, I guess. um, so uh, so yeah, that's what that made me um, think of. Uh, Also, yeah, general description of how Condor works made me think. Uh, I mean, a description of how Condor works, and also like the other distributed systems. Um, the examples that came up, uh, it made me think like the evolution of distributed systems. Uh, uh, sort of mirrors the evolution of like software planning or whatever, like the uh, um, the type of thing that things like agile planning tries to get at. I think is sort of like uh, managing work in a distributed system, um, uh, and yeah. So I feel so. I guess there's like a medium is the message effect of like this the how the systems are distributed, determining how work is done or like planned, I guess. Um, Yeah, those are the things that came to mind. Thank it.
Yeah, I didn't know this thing existed. I found it by asking ChatGPT for good references for distributed computing. So this was kind of interesting because it seems at the same time somewhat technologically obsolete, but not by too much. I wouldn't even call it obsolete. It's like almost a fork that maybe the world didn't go down for various reasons. Like we're talking about the, the matchmaker as a central scheduler node that makes it not truly decentralized. And there's also looks like they had a gateway system for connecting clusters that was also like that, but they got beyond that with some sort of swarming protocol. But you look around, I mean, if you use AWS, you're relying on like Amazon central sort of like orchestration things. I think you have similar problems if you use modern orchestration software, or even if you use crypto, there's like, yeah, single point failure things. Maybe we should read about that too. So, in a way, it's not like we've gotten beyond the problems, but that we've decided to manage them in somewhat different ways. But the truly different thing about this, I guess, evolutionary fork, you could call it, is there's a sort of like public commons sort of vibe to this. This is uh, like today, if I think about it, if I had the technical competence to do this sort of problem solving, and I wanted to solve like a large scale distributed computing problem, it wouldn't even occur to me to put together a system like this or somehow access a system like this. I would go straight to like something like AWS or somewhere and like try and find the cheapest way to provision whatever 1,000 CPUs or GPUs that I need and run the job on that system, right? And it's kind of weird because it's not like this is a completely alien way of thinking. Like as recently as I don't know, 15, 20 years ago, everybody was talking about things like SETI at home and protein folding at home. So we're all, I think, old enough that we remember a time when distributed computing meant scavenging resources from a bunch of small scale resource provisioned things by lots of local actors. And then there was like some public commons ways of um, architecting how to use that, right? But I haven't heard of things like SETI at home for a really long time now, and I don't know if anybody even uses those kinds of paradigms anymore. And in a way, we do have some of that in crypto, like you like something like Farcaster. In theory, runs on a bunch of different hubs running in different places. All crypto systems seem to have networks of nodes, but it's also different because even though there's a decentralized backend, that's not actually an open-ended resource available for anybody to use for arbitrary client workloads. That's mainly used to run the coordination layer of tasks that kind of didn't exist back then. Like when you look at like the decentralized compute layer of crypto, it's solving the trustless computing coordination problem that kind of didn't even exist when people were thinking in the way this paper was thinking. Like Sachin mentioned, this kind of distributed system, uh, trustlessness and open access weren't even considered part of the problem definition. So you would only access this kind of system, I guess, if you were part of a cluster and were within the permission group of the University of Wisconsin or whatever other cluster you were part of. You couldn't like randomly as an anonymous internet actor go and somehow request like 100 computers from somewhere else, right? So in a way, yes, the problem has been rescoped in a more ambitious way, but because of that, much of the distributed computing resources are actually used to solve parts of the problem that didn't exist before. So if you actually wanted to get like a distributed commons public space kind of like way to get say 100 CPUs to work with at any given time. Actually, I don't think there's a way to do it yet. Like there's no way you can do this. You'd have to go to something like AWS and just pay for the private version of this, or you'd have to like I don't know, actually start a social community, kind of like how we start Discord communities these days. You'd have to start a social computing kind of like community and say, hey, 100 of my friends, do you have computers you're willing to put together in a cluster like this? So it's kind of weird that this paper is talking about a problem whose modern version I think still remains unsolved, unless one of you knows something and can correct me. I wouldn't know how to do this other than to go to AWS. But yeah, I think this is actually very interesting, and given like all the growing trust problems about using FANG platforms for everything and having billionaires run infrastructure, I think it's kind of an interesting challenge to put something like this together, and kind of interesting that it doesn't exist yet. I think Holochain was a crypto-ish project that was trying to do something like this, but yeah, I can't think of any like public commons or distributed hardened commons way of doing this. With that, yeah, I think Anuraj and Jenna were on mute today, but yes, if you have stuff to add, please, floor is open. Anybody else? Anybody have thoughts on my question of like, how would you do this today? The problem this system solves, how would you actually attempt to solve it today?
See, it's funny. I actually used, I think it wasn't SETI at home. So I think about 5 or 6 years ago, there was, yeah, there was protein folding at home, I think, or something like that. And there was actually a coin called Grid Coin that was supposedly integrated, and I actually, played around with it because I was just exploring things in the space. And it was a crypto, and you could run a node, but it was also centralized in that it plugged into the whatever, like folding at home or whatever system, such that the idea is that they could give rewards to people who did the thing. So it's like it was acting almost as an incentivization layer. And I thought that was interesting, but for a standalone crypto, that's not enough to really give it any sort of lasting value. And for I can tell, it was pretty much dead. But it is a very interesting idea. And so that's something I've been thinking. And so I guess I don't answer your question of how would I actually do this sort of today. The thing is, when you unshackle from the sort of centralized coordinator, the problems get a lot harder, because at least with the centralized coordinator, you can try to assume that the people you're coordinating are at least attempting to be good faith actors. Whereas if you give up on that, you suddenly have a much bigger security problem that you really already had in the beginning, but you were covering up. And it's really not easy to get. You can design a system. That's not impossible. I mean, you could take something like folding at home and try to add stuff to it, kind of like what Gridcoin did. But I'm not sure you're going to be able to get something that I don't think you can, by itself, you're going to be able to economically incentivize people to actually use your thing. And I don't think you're going to be able to get enough, especially if your system is going to be so complicated. And you're going to be able to get enough altruism to really solve the problem by itself. Anyway, so I guess that's my thoughts on that.
Yeah, this makes what Ben makes reminded me that I guess this might be the thing that a lot of like the social part of crypto is trying to solve. As in, um, like to use Condor, you have to be like a university affiliated student or a professor, and like the crypto equivalent of that is if if you have like Zuzo or and a particular NFT or a collection of those things combined. Um, uh, like while it's not perfect or it's not, but it seems like that's what that social layer of like all the crypto thing is sort of working towards, is basically creating that the parts of trust that are not easily verifiable or something. Yeah.
One thing I forgot to mention earlier. So I've never actually been a part of one of these communities, but I have observed sort of them. So I'm not sure if you know of that. BitTorrent was a big thing, a couple decades ago. Is how people got their legal downloads of movies and so on, and before like Netflix and Spotify moved in to capture those areas. It's interesting to watch how they've evolved. There isn't nearly as much public peer-to-peer file sharing as there used to be, but instead what has sprouted up is these sort of almost cozy web sort of communities of private trackers where you have to, there's generally some kind of web form or something. You have to get into the club, which there's whole guides on how to do this. What you want, there's ways you can try to work in socially and so on. It's very much this is a private establishment here, and you have to try to join the golf club or whatever. But once you get in, they actually do some of this distributed computing. I wasn't thinking about it, but that is kind of what folding at home, what they try to do is anyway. There's like rules and like social conventions, like you have to share as much as you download on a certain time period, or you can get kicked out, and you have to provide content to the community or something. Again, this is from me observing. I've never been a member of one of these things, these private clubs, but it's very interesting. It's funny how they've sort of evolved off into their own little thing. Supposedly, like you can actually get into some that have like huge amounts of content that you can download. Well, for putting finger quotes free, but of course, because it's a private club, there's significant costs, even if they're not monetary costs to get in. And it's very fascinating to think. I wish I kind of want to get involved in that. Not even because I want the movie, but because I want to figure out how these things work, like these communities, because they're kind of unique. I don't know a lot of other communities that are like this on the internet, and they almost are like little distributed things where people are mostly anonymous because what they're doing is technically illegal, sharing movies and whatever. And But it's supposedly that's where all the good content has migrated to off the public torrent networks, and there's like guides on how to set up like a cedar box or whatever, and how you can try to interview, or I'm not sure they call it interviewing, but try to work your way up. And there's supposedly a hierarchy of these clubs where people in the upper levels will recruit from the lower levels. So I mean that, and it's funny because it's totally not crypto. It's very not anti. It's a very different direction that crypto took, as opposed to making things public and permissionless versus very private, very permissioned, and fundamentally centralized, but still very distributed and still pretty anonymous. So I'm certain there's very interesting lessons to learn from these private tracker communities, though I'm not 100% sure what they are. I guess is where I would put my. Anyway, that just reminded me of this. Yeah, I guess I'll stop blabbering about that.
Yeah, in a way, the cozy retreat at all levels, going from just social hangout kind of groups all the way down to like infrastructure sharing. It's, I guess, a practical response to how hard security is, but it's also a little bit, I don't know, disappointing because it feels like the high value vision is to figure out how to actually do the public and permissionless thing more efficiently and cheaply. I just posted a cast on Warpcast framing this as a conjecture. So here's my conjecture, which is if you take any computing system from mostly closed and permission to mostly open and permissionless, the compute workload of security assurance goes from being 1% of the workload to 99% of the workload. So to retain the same functional bandwidth, the system would need to be 100x larger. So to make it concrete, if you have like a system designed to support, say, 10 people doing some sort of work and the 10 people all know each other, and now you want to move to a scheme where it can still support 10 people, but these 10 people now don't need to be friends and can be completely arbitrary people who happen to want the same resources. The system would now need to be 100 times larger to solve the security assurance problem. This is my conjecture. I don't know if it's true, but it feels like this can be much more efficient. Like maybe it doesn't need to be 100 times bigger. Maybe it can just be 10 times bigger. But also I think there's like some sort of like fundamental law of the universe here, like a second law of thermodynamics or something, because open systems have just so much more of like a unconstrained security environment. There's no way you're going to get the efficiency of this phase change of opening up to like, just like 1 or 2 percentage points. It's going to be at least an order of magnitude, I think, if not more. So that's my conjecture here. But it feels worth doing because if you have enough abundance, if you have resources you can waste, it feels worthwhile to make systems permissionless. Like if you can afford to waste the resources, why not have a system be completely open and permissionless? So something like, I guess there's a politics here where it's like, so long as there's enough abundance, things should be borderless and open. Like in like physical politics, I tend to lean towards, can we make the world a completely borderless place? Like, why shouldn't it be? Humans are the only species that kind of impose borders and stuff. And that's partly because we have much more powerful abilities to travel. But if you look at other species, they don't divide the world up into countries with borders and visas and passports. But that's partly because, cats and fish and other animals can't travel as efficiently as we can. So yeah, there's, I think, a general philosophical point here that even if it's expensive, it's a worthwhile vision to work towards. How do you make systems open and permissionless? Yeah. More thoughts?
I mean, it's listening to all of this makes me kind of speculate that in hindsight, it seems 20 years later, the way the public commons problem solved in some sense to have access to these computational resources in a commoditized manner, it seems to be the market-based dynamics that has taken over in some sense, and the security and the protections that comes with it in some sense. But although, I mean, they're not hard in terms of full security they can guarantee, but kind of interesting to see how that has evolved 20 years since.
I would argue that the market is not actually solving the problem. Like the CrowdStrike failure is an example of the market trying and failing to solve the problem. So you have like a threat environment, and then you have like a system point of failure infrastructure relationship, and then without even an active threat, the whole thing falls on its ass because somebody fudged an update, right? So I think this is actually a case where market failure is happening. So even though the market is the solution we use, it's already, like somebody was joking that hey, CrowdStrike CEO, you've probably met your net zero or carbon mitigation goals in just one day because of like the amount of shutdown that market solution here, an actual solution. It's a market failure. And last couple of minutes, any last thoughts? All right, then. We'll call it a few minutes early today. So see you guys next week.